if you had completed anything over break, there'll be time at the end of the period. I will just let me know what you're showing me, and I can easily put that in for you, okay? Friends, we have this week and next week, and the week after, we basically start finals. Okay, so my goal for this week is we're going to start solving systems of linear equations. So we'll do 1 and 2 tomorrow. We'll then review on Wednesday. Our review will be graphing systems and then going over a line of best fit, because we'll have a quiz on Thursday on the graphing of these, and then one of the line of best fits. Yeah. Yes. I don't know. Well, I am on page 197. Thank you. Page 197. Okay, so my goal for you all, if you, in the next couple of weeks, or next couple of days, be better, if you take a look at your Power School grade, if you see a 0 in there for whatever reason, go back in your book, see if you have it. If it's not done, get it done. If it's done, make sure you show me. Or, bless you, if you get it done, show me as well. Because those zeros can add up. They can, move your grade in a positive direction. So, those are a few things that you all should just take a look at. Just know about your grade. If you owe me a test or a quiz, make sure you're getting that made up with me. And just come in on one of your off periods. It doesn't matter if I'm teaching or not. I mean, if I'm not teaching, I'm next door. If I'm teaching, I'm in here. So come on in, sit down. We can have you finish that, okay? So, solving systems of linear equations. Let me see. I'm going to match this up with, I think that's our first page. Cool. Okay, so a system of linear equations is basically where two lines would intersect each other if you had graphed them. Now we're going to go over 3 different methods on how to solve a system of linear equations. I don't have the videos up for this chapter yet for the odd homeworks, but I should. I'll start working on it today, see how far I can get. Should be able to get that if you're utilizing that. But if not, we can go through them in class. So let's jump in. So this particular one is set up like y equals mx plus b. Agreed? So my b value is 0, 1. So I'd plot that dot. And then my slope is going to be 3 over 1. So from the dot that I just made, we're going to go up 3, right 1. And then with a straight edge, and I know a lot of people, you might use your ID as your straight edge. So I don't know if I can do mine or not on the electron. Now I'm not going to even try it. So with a straight edge, again, your ID is a good straight edge. It doesn't have to be a ruler. But I'm going to go ahead and graph this. That's my phone. I'm sorry. Put this on the silent. How do you make it silent? Is it swipe up and then put the moon? Okay. I'm so sorry about that. Okay, so we're now looking at the second one. I did it in green. This one appears to be the cover method. Agree? Which is 0, blank, blank, 0. So this is an x value, so cover up the x, so the y value would have to be 6. So 0, 6. 3, 4, 5, 6. And then, let's see. This is a y value, so cover up the y. So 2 times x is 6. 2 times what number gives me 6? And that would be 3. Okay. Let's do a straight edge. We'll do it as green. So, first thing. Do these lines cross? Yeah. They do. Everyone agree? Okay, so they cross. They cross each other. So you find the ordered pair. You find exactly where they cross. So it looks like 1, 2, 3, 1, 2, 3, 4. So 1, comma 4 is where they cross. That's the solution to the problem. That's excuse me. That's the point that both of the lines have in common. If I took the x value being 1 and the y value being 4 and I plugged it into both equations, you would get a true statement, meaning the top one would be 4 equals 4, the bottom one would be 6 equals 6. Yep. Okay. So if you were to plug these in, the top equation is going to become 4 equals 3 times 1 plus 1. So 4 equals 4. That works. Now if I plugged in the other one, I'm going to get 2 times 1 plus 4 equals 6. So 2 plus 4 is 6. 6 equals 6. It checks. That's the solution. That's what unlocks the door. Seem okay so far, my friends? Pretty straightforward. We've seen graphing before. Right before break, we were working with line of best fit, which was 2 data points. So we'll have something like that on the quiz as well, but we'll review that. May I move on to the next slide? So all your answers on this problem is 1, comma 4. That's all you have to put. So you graph it. Try and have a straight edge. Try and graph it as straight as possible so you can see exactly where it intersects. If you make your graph, kind of silly, this might be, where does this really happen? If you didn't use a straight edge, you might not be able to see it. Okay, so this is our next one. These are both as y equals mx plus b. So 0, comma b is the y-intercept, and my slope, make it a fraction if it's not already. So my y-intercept of this first one is 0, comma 5. So 0, comma 5, put a dot. My slope is going to be 1 over 1. So from this point, I'm going to go up 1, right 1. And draw in your line of best fit. There's my line of best fit. Yes, you can put arrows on both sides of the line if you wanted to. And then this one, my y-intercept, I have to realize I could put plus 0, so my y-intercept is going to be 0, 0. And my slope is going to be negative 4, make it a fraction, so negative 4 over 1. So I'm going to go down 4, right 1. And if you drew it correctly, do these lines cross? I'm pretty sure they do. So you look, say, okay, what does this point appear to be? Now, that point doesn't have to be always exactly. We'll make them exact points. So don't give me an answer of like, oh, it looks like 1.6, comma 3.7. We'll make it so they'll come out whole numbers. So this looks like it'll be the point negative 1, comma, negative 1, 1, 2, 3, 4, negative 1, comma 4. And that's the solution to the answer. That's all you have to do. Seem A-okay, my friends? Okay, so again, if I took this x and this y value and plugged it into my originals, top one would be 4, because that's our y value. Negative 1's our x value, plus 5, so that's 4 equals 4. That's true. If I plugged it into the bottom one, I get 4 equals negative 4 times negative 1. Negative 4 times negative 1 is positive 4, so that checks on both. So that verifies we have the solution to the problem. Yeehaw, saddle up and ride. Seem okay so far? Everyone's happy, content? Okay. So, now, we don't have to graph these. They just want to know, hey, is this a solution? Well, we have to know that's an x and a y value. So the x value will get plugged in here, and the y value will get plugged in here. You have to plug it into both to make sure it works on both. So I'm going to get negative 3 equals negative 2 times 4 plus 5. So negative 3 equals negative 8 plus 5. Negative 8 plus 5 is negative 3. Negative 3 is indeed equal to negative 3. Okay, so it works on the first one. Plug it into the second one. I'm going to get 4 plus 2 times negative 3 equals negative 2. 4 minus 6 equals negative 2. Negative 2 equals negative 2. I get a true statement on both. So is this point a solution? Yes. That's where if I'd graphed them, it would cross. Yeah.
If it was only a solution to one of the problems, would it not be a solution to the whole thing?
Yeah. That's why we want to plug it into both. And I will tell you on the quiz, I will probably have one of the problems that will work on the first one and not on the second one.
And then it won't be a solution.
Then it is not a solution to the system. Okay? Because the system would be 2 or more things graphed. All right, second problem. I'm going to take my x value and plug it in for my x's. Now I'm going to take my y value, plug it in for my y's on both. So this one will be 3. My x is 1 minus 5. Is that equal to negative 2? Well, 3 minus 5 equal negative 2. I believe so. So it works on the first. Do it on the second one. I'm going to go 5 equals 2 times 1 minus 3. 5 equals 2 minus 3. So 5 is equal to negative 1. Is 5 equal to negative 1? No. So it worked on one, but not on the other. So this is not a solution because it did not work on both equations. Now it's possible these two lines, if I graph them, they would indeed cross. Okay, but they would not cross at 1, 5 because mathematically it didn't work when I plugged it into both. Oh, that's so colorful. That looks good. I like that. Okay, ready? All right, how many solutions will the system have? So this first one has one solution. Okay, you solve it just like normal. Okay, just if you graph it, you find that it crosses there, you give the ordered pair. If it has one solution, the solution to this would be 3, negative 1. That's the solution. But then you come across a situation where you have two lines that are parallel to each other. Parallel lines don't cross. So this has no solution. Okay? No solution means my lines won't cross. If they don't cross, there's not an ordered pair I could say where they intersect. And then my third one is kind of hard to see. But we have two equations given, but only one line. This means it is the same line. So this has infinite solutions. Okay? So if you graph one line and you graph another line and they both lie on top of each other, that means you have infinite solutions. So there's 3 categories that can happen. Okay? If you come up with a no solution, actually, I'm not even going to touch that yet. There is something that when we start doing the substitution and the elimination method, there's something special that happens, but I'm not going to get there yet. So right now, if you graph it, you know you have two parallel lines. You can tell they're parallel lines because of the same slope. Okay? If you have two parallel lines, obviously the same slope, they will not have a solution. So you really either have a question says, hey, how many solutions does it have? If it has a solution, tell me. You can say, hey, I have one solution, and my solution is 3, -1 in this particular case. I have no solution, which that would say that, or you would have the understanding to be parallel lines. Or if they were infinite solutions, they obviously have the same slope if they have infinite solutions, but it's the exact same line. Okay, so it's the exact same linear equation. Okay, to get us back kind of in the meld of stuff, I am going to go ahead and give us the assignment to start now and give you the opportunity, because I know you're back at school, so you're like, okay, you got some of these teachers that are going to say, hey, there's 2 hours of homework tonight. And you're like, what? You're crazy. So why don't you get a good start on this? I will come around and help you. As I'm helping you, if you have old assignments that I need to be aware of, that are ready to be checked off, I will go ahead and take care of you. And in about at 10:40, you are allowed to get your phone. Cool? All right, let me hit leave.